So how do you find the sum of the interior angles? So we start off by the simplest polygon or the most basic polygon, which is a triangle. And when we talk about some of the interior angles, we're talking about the angles inside it. So for a triangle, it would be adding these three angles, right? If there's a difference between what we call a regular polygon and just a polygon, right? So the difference between a regular polygon and a non-regular polygon is the fact that a regular polygon is going to have all lengths, all side lengths the same, which in return is going to have all interior angles that are congruent, right? So, but it doesn't matter for the sum of the interior angles, because here's why. So, if we have a triangle, if we break it down to its basic form, a triangle has three sides, and that's what we're going to denote by n, right? So here n is 3. So n equals 3. And we only have one triangle, right? It takes three sides to create one triangle. So we have one triangle here. And if we were to add up all the angles inside this triangle, it doesn't matter what they each measure. What matters is what they add up to. And we've known since I think 7th grade maybe, that if you add up all the angles inside a triangle, they add up to 180 degrees. And so we look at a quadrilateral, right? So quadrilateral, any four-sided figure. And in this case, we're trying to figure out what is the sum of the interior angles in here. Not necessarily a rectangle, although it looks like a rectangle. What we can do is we can break it down into triangles, right? So here, I can fit one triangle. So here's my one triangle there, and then here's my second triangle, and we can break it down again. So if I add these three, that is 180 degrees from that triangle, and then if I add these three angles, that's another 180, and so all together, when we add them together, we get 360 degrees, right? So here, my quadrilateral, my number of sides is going to have 4, and I was able to fit 2 triangles in here. Okay, now a pentagon has 5 sides, so we have n equals 5. And we're trying to figure out how many triangles can I fit in here. So remember, we need 3 sides to create a triangle, so I'm going to start here. And so here's my first triangle that I can fit. I can fit a second triangle here. So we got 2 triangles so far. And that leaves me with a third triangle here, right? And so remember the fact that we know that each triangle adds up to 180 degrees, right? So here we were able to fill, or we were able to get 3 triangles from here, which is telling me we're going to add 180 3 times, which takes us to 540 degrees, okay? And we should try to start seeing a pattern here, okay? So hexagon is going to have 6 sides. And we're trying to figure out how many triangles can I fit in here. Well, here's 1, here's 2, here's 3, and then 4, right? So here's 1, 2, 3, 4 triangles, which is telling me that if I have 4 triangles, I'm gonna add 180 4 times, which takes us to 720 total degrees, right? So those are the sum of the interior angles. And again, we should start seeing a pattern here, right? So a heptagon has 7 sides. So here n equals 7, and see how many sides can we, or sorry, how many triangles can we find in here? So starting at this vertex, we're gonna go 1, that's 2, that's 3, and that's 4. So 1, 2, 3, 4, and then the 5th triangle is there. So here I have 5 triangles, which is telling me that I'm going to add 180 degrees 5 times, which takes me to 900 degrees. Okay. Again, we should start seeing a pattern here. Now, if you see it, great. See if you can come up with a general formula to how to find the sum of the interior angles. But let's keep going just in case you don't see the pattern, right? So an octagon has 8 sides. How many triangles can we fit inside an octagon? So here 1, 2, 3, 4, 5, and 6. That's telling me that if I add up 180 degrees 6 times, because I have 6 triangles, that would give me 1080 degrees. All right, so let's keep going. So nonagon is going to have 9 sides. And if you don't see the pattern, let's go back. Okay, so here we started off with 3 sides, gave us 1 triangle. 4 sides gave us 2 triangles. 5 sides gave us 3. 6 sides gave us 4. And now we're following that same pattern where we have 7 gives us 5. 8 sides gives us 2. And so we kind of see the pattern here that for every number of sides, we can fit 2 less triangles, right? So for a polygon that has 7 sides, we subtract 2 and we get 5 triangles, right? So an octagon, it has 8 sides. We subtract 2, we get 6 triangles. And so we follow that pattern. For a polygon that has 9 sides, we subtract 2, we're going to get 7 triangles, which is telling me that I'm going to add up 180 degrees 7 times, which gives us 1260 degrees. And so we follow that same pattern. A decagon, 10 sides, that means we can fit 8 triangles, which gives us 1440. Now, yes, we can add, right? So we can add 188 times, we can add 187 times, we can add 186 times. But a faster way would be to multiply, right? So 180 degrees, because that's how many degrees there are in one triangle, multiplied times 5 gives us the sum of the interior, right? So 180 degrees times 6 gives us our sum of the interior. 180 degrees times 7 gives us our sum of interior. And so we come with a formula here, a general formula, right? So we're going to call it S for sum of interior angles. So S is going to equal to, so all of this comes down to the type of polygon that you have, right? So the type of polygon that we have is determined by the number of sides, which we are calling n. And that n, the number of sides, we subtract 2, and that's going to tell us how many triangles we can fit inside that polygon. And all that's left to do is whatever number we get, however many triangles we get, we multiply times 180, and that gives us our sum of our interior angles.